Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to convert names of ionic compounds to the formulas using what is called the crossover method. So let's get into this. I'm first going to go over some steps to follow when you're doing this converting from a name to the formula for ionic compounds. And then I'll go over some examples that'll make it clear if it's not clear after going over the steps. Okay, so here are the steps. So the first step is to write the formula of the cation with the charge. So when you're given the formula, you should always remember that the first element is going to be the cation. Or if it's a polyatomic ion, it's going to be the first, couple of elements depending on, for example, if it's ammonium, it's going to be NH4. So if you have NH4 at the beginning, that's going to be your cation. But normally it's going to be just a single atom, a metal. So if you have aluminum in there, then aluminum would be first in the formula. So you're going to write the formula for the cation with the charge. That's important. You got to know the charges and you got to write the charges down. Second, then you're going to do the same thing for the anion. So again, for those of you who don't know, the cation is the positive ion. The way I like to remember that is with the T in the cation. It looks like a cross, looks like a plus sign. So cations are positive, anions are negative. So then the second step is to write the formula of the anion, again, with the charge. Then, once you've got those written down, you're going to do the crossover. What is the crossover? That's where you take the numbers of the ions, right? So you got the positive ion, negative ion. You got the numbers, right? So maybe it's a -1 or a +2, whatever it is. You're going to take the numbers, ignore the plus and minus, right? The plus and minus don't matter. You're just going to take the numbers and you're going to crisscross them down and write the numbers for the other atoms as subscripts. So you're going to write them as subscripts for the other element, right? So that's what it says here. Take the number of the charge for each ion, and you're going to write them as subscripts for the other ion. So you're going to crisscross. So you're going to start here, and then you're going to crisscross down as subscripts. Here they're as superscripts, as charges, and then you're going to crisscross and write them as subscripts for the other ion. And again, if this isn't making sense, I'll go over some examples in just a moment. After you do the crisscross or the crossover method, you want to reduce or simplify the subscripts to get the lowest whole number ratio. So if you've got 2 to 4 as subscripts, that can be simplified to 1 to 2, right? If you've got 3 to 5, well, that's not going to be reducible. You just keep it that way. So if you can reduce it to simpler whole number ratio, then do that. And then finally, if the subscript of a polyatomic ion, so if you got a polyatomic ion in your formula, and when you do the crossover method, if you end up with a subscript that's greater than 1, then you need to put parentheses around the polyatomic ion, and you want the subscript on the outside of that polyatomic ion. Again, I'm going to go over a few examples in just a moment, but I hope this is at least somewhat clear. And then I'm going to just go over a few examples right now. Okay, so here are some examples that I have that I'm going to go over. So let's follow the steps. So let's start with sodium chloride. So step 1, write down the formula with the charge of the cation. Remember, the cations are going to be written first. The positive ions are always written first in your name. And then the second ion, or the second part of your name, is going to be the negative ion, the anion. So cation, anion. So we're going to write the formula for the cation first. That's sodium. And because you know that sodium is in group 1, the group 1A, that's going to be a +1 charge. So we're going to put a plus there. We don't write the ones. It's there. So Na+, and then chloride, that comes from chlorine. So it's going to be Cl. And that's in group 7A. And we know that group 7A elements have a -1 charge. So we're going to put a minus. So that's a -1. And then we're going to do our crossover, step 3. So we're going to cross over. So we have ones here. So I'm going to just write the ones so you can see them. And so with the way the crossover method works is I have a 1 here. I'm going to write that as a subscript for the chlorine. And this one here, I'm going to write that as a subscript for the sodium. And so then it becomes Na1Cl1. And again, of course, we don't write the ones. We never really write ones in our formulas. So it's just going to be NaCl. So that's the formula for sodium chloride. Okay, let's try ammonium sulfate this time. So ammonium, that's our positive ion. That's going to be a cation. So you got to know the formula for ammonium. And that's NH4 plus. So again, it has a +1 charge. So we're going to just write plus there. And then we got sulfate. That's another polyatomic ion. So you have to know the formula for sulfate. That's going to be SO4. And it's got a 2- charge on it. And so now we have our two ions. We got the cation and the anion. And so we're going to do our crossover. So again, I'm going to write the 1 here just so you understand what's going on. So I'm taking the 1 and I am going to write it as a subscript here for the sulfate. And I'm going to take the 2 and I'm going to write it as a subscript for the ammonium. And notice I'm ignoring the charges. I'm not writing charges or anything like that. So here, this 2 is going to be a subscript for the NH4. Now, because this is a polyatomic ion and my subscript is going to be greater than 1, I got to put parentheses around the NH4. So I'm going to put NH4. I'm going to put parentheses around that. And then I'm going to put the 2 on the outside of the parentheses. So there's my subscript 2. And then the subscript here is a 1. And so because the subscript for this polyatomic ion is 1, I don't need the parentheses. So I'm just going to write SO4 like so. And so therefore now I have 1. We don't write the 1 subscript here, but this is the way the formula is now. So this is the formula for ammonium sulfate. Right? So if I was to put the 1, right, let's say if I put parentheses, I could put the 1 like that. I mean, you would understand what that means, right? So I have polyatomic ion in parentheses with a 2, and then the polyatomic ion here with the 1 out there. That makes it clear that you have a 2-to-1 ratio that isn't going to be reducible, right? So this is the 1-to-2 is the simplest or most reduced form that you could get. Now, again, we don't write the parentheses in here. But if there's no parentheses, you got to be careful about reducing, right? So if I remove the parentheses here, this is really important to keep in mind, right? So this is the way we normally write the formula, NH4 to SO4. NH4 is in parentheses, of course. Now, when it comes to reducing your subscripts, please, please, please don't make the mistake about reducing this 2 and 4. Don't try to reduce this to 1 and 2 because this 4 here is not reducible because this is part of the formula of the sulfate. If you change that, then you've changed your ion. You've changed the substance. It's no longer going to be ammonium sulfate. It's going to be something different. So be very careful about reducing. Make sure you're reducing the correct subscripts, okay? And those should be the subscripts that apply to the whole the polyatomic ion. Okay, so watch out for that. All right, next is lithium phosphate. So again, we're going to write the formula for lithium. That's going to be Li, and that's got to be a plus because it's in group 1, so it's got a +1 charge. We like our group 1 elements, I guess. Next, we have phosphate. So that's a polyatomic ion. So that's PO4, and this has a 3- charge on it. Now that we have our two ions, we're going to take the numbers of the charge and cross over. So then the 1 here, that's going to be a subscript for the phosphate, and the 3 here is going to be a subscript for the lithium. So this ends up being Li3, and then a 1 for the phosphate. So again, just to make it clear, I could write it like this with a 1 on the outside. So the 1 here and the 3 here are as simple as it can get. They're not reducible. This is not easy. You can't really simplify 1 to 3. That's it. And so that makes it obvious. But again, we don't write the parentheses if you've only got one polyatomic ion. So we don't need that. So again, we don't really write the ones. So this would be the formula as is. So Li3PO4. Okay, next we have magnesium nitrate. So again, step 1, write the formula for the cation magnesium. So in this case, magnesium is a group 2 element. So that's going to have a 2+ charge. And then nitrate again is a polyatomic ion. So that's going to be NO3, and that's going to have a -1 charge. So again, we don't write the ones. And so now that I have my cation and anion written, now I can do the crossover. So then I'm going to take the 2 for the charge here. I'm going to write that as a subscript for the nitrate. And the 1 here, that 1 is going to be a subscript for the magnesium. So again, we don't write the 1s for the subscripts, so we're just going to write Mg. So there's 1 there. Or we could write it, but we're going to get rid of it soon. So the 1 goes down there. And then the 2 goes down here. So this 2 subscript applies to the NO3, which is a polyatomic ion. And so I'm going to put parentheses around that. So it's going to be NO3 parentheses with a 2 on the outside. And so, of course, we're not going to have that 1, so we can get rid of the 1. So that would just be MgNO3 2. And finally, we have calcium carbonate. So calcium, again, is going to be in group 2. We're going to write down the formula for that. So that's Ca. It's got a 2+ charge because it's in 2A, the group 2A. All elements in 2A have a 2+ charge because they want to get rid of those 2 valence electrons. And now we have our carbonate, another polyatomic ion. So this polyatomic ion is CO3 with a 2- charge. And so here, now we have our cation anion. So now we're going to go cross over. So the 2 for the calcium here, the charge here, the 2 becomes a subscript for the carbonate. And the 2 here becomes a subscript for the calcium. And so we get Ca2. And since this is a 2 subscript, that's greater than 1, we're going to have to put parentheses around the CO3. So it's going to be parentheses CO3 with a 2 on the outside. Now, this is where you're going to have to reduce because look at the 2 here and the 2 here. So when you have parentheses, you're always looking at the subscript on the outside of the parentheses, not on the inside. So the 2 and the 2 here, both of these are outside the parentheses. So we're looking at this 2 and this 2. That is reducible. We can simplify the 2 to 2. And we can simplify that 1 to 1. We can reduce that to a 1 to 1 ratio because 2 to 2 is the same as 1 to 1. So we'll simplify it. And since we don't write the ones, we're just going to get rid of them. So this becomes, that becomes a 1, that becomes a 1. And so we get CaCO3. And notice I don't need the parentheses anymore because I have a 1 subscript. So I get rid of it and it's CaCO3. And so that, ladies and gentlemen, is how you use the crossover method when you're trying to convert the names of ionic compounds to their formulas. I hope this video was helpful. If this was entertaining or interesting or helpful, if you learned something from this video, then please, by all means, like the video, share the video, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click that notification bell, and also make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question that you want me to answer, if you have a problem you want me to go over, or maybe even a topic that you want me to cover, please put it down below in the comment section, and I'll be happy to do that for you. Thanks for joining me, and have a great day.